So, to get into logarithms and how to use them, you need to understand what is happening with exponential equations. So, when we have the variable that we're working with, when our x, usually x, is the exponent, that's an exponential equation. If we have a number for the exponent, that is not an exponential equation. So, does anybody know what part of the equation a is? So a is actually the starting value. In real terms, we'll do an example in just a moment. But a is the value where you start. B is what's called our multiplier. With a linear equation, if you had an XY table, as your x's are going up, your y's are going up by a consistent amount, meaning the same amount is being added every time. With an exponential equation, the difference between the linear and exponential is the rate of change is not constant with exponential. It's actually being multiplied by the same number every time, so it's going up a lot faster. So what's happening on the negative end is we are very, very close to 0, and then we go up, and once we cross into the positives, we go up very, very fast. So this graph, this would have been of, say, y equals 2 to the x. If I have 2 to the negative 10, whoops, you can't see that. If I have 2 to the negative 10, that is going to be 1 over 2 to the 10th, which is a very large number for the denominator, which makes it a very, very small fraction. So as we go down in this direction, we get closer and closer to 0, but we will never actually meet 0, which means we have a horizontal asymptote at y equals 0, because there is absolutely nothing that we can put in for x that will make y come out as 0. So if we have our equation, y equals, what's our starting value? 250,000. Times our rate, which is going to be the 1 for our 100% that we start with, plus our 0.03, the 3% that it's growing by. So that's our 103% every year, so as a decimal, and I'll rewrite this as well. And that is to the power of x. What does x represent in this particular situation? Years. And what does y represent? Total value. So if I want to rewrite that without it being 1 plus 0.03, 250,000 times 1.03 to the x. And that's my exponential equation for the value of that house. If, on the other hand, I am depreciating, meaning I am decreasing, or the house is decreasing in value at a rate of 3% per year, how is that going to be different? What will be different on that equation? Not times 0.03.
Oh, would you say
Decreasing
decreasing?
by 3%. It would be 0.97. Because it would be our 250,000, and then our, whoops,
Or divided.
1 minus 0.03 to the x. So if I rewrote that, so you can see it as just a single number, 50,000 times 0.97 to the x. because if it loses 3%, what I have left is the 97% at the end. So, that is kind of a rough overview of exponential equations. Hopefully it's a review, but if it's not, hopefully that part made sense.